In me the demons call when they do what they do. And now I feel like taking off, find a place with a view. The pain is never gonna stop if it's controlling you. I know that time can heal it all, I just gotta get through. I just gotta get through.
Amazon Virtual Private Cloud, VPC Overview. Amazon Virtual Private Cloud. Amazon VPC is like your own private cloud within the AWS cloud. It lets you provision a logically isolated section of the AWS cloud, where you can launch AWS resources in a virtual network that you define. This is a virtual network dedicated to your AWS account. Alternatively, your AWS account comes with a pre-configured default VPC in each region. You can launch your resources into the default VPC right away. Amazon VPC also provides you with complete control over your virtual networking environment, including selection of your own IP address range, creation of subnets, and configuration of route tables and network gateways. To get started with creating a VPC, you must assign it with a range of private IP addresses. Amazon VPC supports IPv4 and IPv6. Your resources can communicate over IPv4 or IPv6 or both. By default, it uses the IPv4 addressing protocol. You can also bring your own IP prefixes. A VPC spans all of the availability zones in the region. After creating a VPC, you can add one or more subnets in each availability zone. A subnet is a partition of a VPC's IP address range. For example, your VPC has a total of 1024 IP addresses, and you configure 4 subnets, each has 251 IP addresses. Each subnet must reside entirely within one availability zone. You can launch instances into subnets in multiple availability zones to improve fault tolerance and hence, building highly available applications. Creating multiple VPCs is supported. In one AWS account, you can create up to 5 VPCs per region by default. If more is required, this limit can be increased through AWS support. Now, let's talk about the key benefits of Amazon VPC. First, it is simple. Using the AWS Management Console, VPC can be quickly and easily created. You spend less time setting up and managing, so you can concentrate on building the applications that run in your VPCs. Customizable. You can easily customize the network configuration of your Amazon VPC. For example, you can create a public-facing subnet for your web servers that have access to the internet. You can also place your backend systems, such as databases or application servers, in a private-facing subnet with no internet access. When you configure VPC to connect to your corporate network, it can serve as an extension of your own data center. In addition, VPC can also be connected to other VPCs. Secure. Amazon VPC provides multiple layers of advanced security features, such as network access control lists, NOCLs, and security groups, to enable inbound and outbound filtering at the subnet and instance level. In addition, you can store data in Amazon S3 and restrict access, so that it's only accessible from instances inside your VPC. Amazon Virtual Private Cloud, VPC. Internet connectivity. An internet gateway is horizontally scaled, redundant, and highly available by default. It allows communication between your VPC and the internet. Internet gateway supports both IPv4 and IPv6 traffic. To enable internet access for instances in a VPC subnet, you must attach an internet gateway to your VPC, add a route to your subnet's route table and point your route table to the internet gateway. Make sure your instances have public IPv4 address, IPv6 address, or elastic IP address. An elastic IP address is a static, public IPv4 address. Static means it does not change over time. You can rapidly move an elastic IP address from one instance or network interface to another. Lastly, ensure that your network access control lists, NOCLs, and security groups allow the relevant traffic to flow to and from your instance. On the other hand, you need a NAT gateway in the public internet to enable instances in a private subnet to connect to the internet, but prevent the internet from initiating connections with the instances. NAT stands for Network Address Translation. When traffic goes to the internet, the source IPv4 address in the private subnet is translated to the NAT gateway's address at the public subnet. Similarly, for the response traffic, the NAT gateway translates the address back to the instance's private IPv4 address. To create a NAT gateway, you must specify the public subnet in which the NAT gateway should reside. You must also specify an elastic IP address to associate with the NAT gateway when you create it. After you've created a NAT gateway, you must update your route table for your private subnet to point internet traffic to the NAT gateway. Note that NAT gateway are not supported for IPv6 traffic. For IPv6 traffic, you would use an egress-only internet gateway instead. It allows outbound communication over IPv6 from instances in your VPC to the internet. At the same time, it also prevents resources on the internet from initiating communication with your instance directly. An egress-only internet gateway is stateful. It forwards traffic from the instances in the subnet to the internet, and then sends the response back to the instances. To route traffic from instances in your private subnet to the internet, you would need to add a route in the route table and point all internet-bound IPv6 traffic to an egress-only internet gateway. Amazon Virtual Private Cloud, VPC concepts. The following are some of the key concepts for VPCs. When you create a VPC, you must specify a range of private IP addresses for the VPC, in the form of a classless interdomain routing, CIDR block notation. The allowed CIDR block size is between a /16 and /28. For example, this IPv4 CIDR block, 10.0.0.0/16 notation, when you write this out in 32 bits binary, you get the following. The number followed the slash symbol, in this case, 16, means that the first 16 bits remains fixed. And you can vary the next 16 bits, providing you with a total of 65,536 IP address ranges. A CIDR block of 0.0.0.0/0 would allow access to any IP address. To the original primary CIDR block, you can assign additional private IP addresses, a secondary CIDR block, to expand your VPC. Private IP addresses are local addresses in your VPC. They are not reachable over the internet. They are used for communication between the instances in your VPC. To connect to your instance over the internet, you can assign a globally unique, public IPv4 address to your instance. On the other hand, IPv6 addresses are public and reachable over the internet. When you create a VPC with CIDR block, such as 10.0.0.0/16, note that you will not have all 65,536 IP addresses. It is because 5 IP addresses are reserved by AWS for internal use. To create more than one subnet in your VPC, make sure that the CIDR blocks do not overlap. That's why we specify 10.0.10.0 and 10.0.20.0 for the two subnets. /24 indicates assigning 251 IP addresses for the subnet. When you create a VPC, it automatically has a main route table by default. You can also create your custom route tables. A route table contains a set of rules, called routes, that are used to determine where network traffic is directed. Each route in a table specifies a destination and a target. This main route table shows a local route that enables communication for all resources within this VPC. Each subnet in your VPC must be associated with a route table. You use a public subnet for resources that must be connected to the internet, and a private subnet for resources that won't be connected to the internet. You can make a subnet a public subnet by adding a route in your subnet route table to an internet gateway to support inbound and outbound access to the public internet. On the other hand, private subnet does not have a route to an internet gateway in the subnet route table. Also note that most architectures allocate significantly more IP addresses available for private subnets than for public subnets. Amazon Virtual Private Cloud VPC. Network Access Control Lists and Security Groups. First, let's look at Network Access Control List. A Network Access Control List, NACL, is the firewall at the subnet boundary. Your VPC automatically comes with a modifiable, default network ACL, NACL. The default NACL allows all inbound and outbound traffic. You can also create a custom NACL and associate it with a subnet. Each custom NACL, by default, denies all inbound and outbound traffic until you add rules to allow traffic. You can associate multiple subnets to a NACL, but only one NACL can be associated with a subnet at a time. Network ACLs, NACLs, are stateless and require explicit rules for both inbound and outbound traffic. It contains a numbered list of rules. Rules are evaluated in order, starting with the lowest numbered rule representing the highest priority, to determine whether traffic is allowed or not. As soon as the traffic matches the rule, the allow or deny rule is applied, and evaluation ends. You can configure allow or deny rules to restrict traffic, based on the type of traffic, protocol, port range and source of traffic. On the other hand, security group acts as a virtual firewall, at the instance level to control inbound and outbound traffic. By default, a security group denies all inbound traffic, and allows all outbound traffic. When you create a new security group, you can define allow rules to control incoming and outgoing traffic that is allowed to reach the instance. There is no deny rules required, because by default, it denies all inbound traffic. Security groups are stateful. Responses to inbound traffic are automatically allowed to flow out of the instance. Unlike NACL, all rules of a security group are evaluated before deciding whether to allow traffic. Traffic can be restricted by traffic type, IP protocol, port range, and traffic source. Now, let's look at how you can chain security groups together to control traffic in this example. Most organizations create security groups with inbound rules for each functional tier. For example, in this architecture, we have web tier security group, application security group, and database security group in each tier. The inbound rule of the web tier security group allows internet traffic from anywhere on HTTPS port 443. At the application tier, the inbound rule of the application security group only allows traffic from the web tier security group on HTTP port 80. In other words, it can only accept inbound traffic from the web server, but nowhere else. At the data tier, the inbound rule of the database security group only allows traffic from the application security group on TCP port 3306 and nowhere else. By chaining the security groups together, you can strictly control the flow of traffic from the top tier to the database. Even if someone were to be hijack the web server somehow, they still wouldn't be able to access the database directly. Amazon Elastic Compute Cloud EC2 Overview. Storage and Networking. Amazon EC2 provides you with flexible, cost-effective, and easy-to-use data storage options for your instances. Instances can access storage from disks that are physically attached to the host computer. This disk storage is referred as Instance Store, which provides temporary block-level storage for your instance. You can also attach an Amazon Elastic Block Store, Amazon EBS volume to your EC2 instance for persistent block-level storage. EBS behaves like a raw, unformatted, external block device. Your EBS data can be backed up using EBS snapshots and stored in Amazon S3. Amazon EC2 also uses Amazon S3 for storing Amazon Machine Images, or AMIs. In addition, you can also create a file system for use with Amazon EC2. Amazon Elastic File System, EFS, provides scalable file storage. Applications running on your EC2 instances can access your file system at the same time. Networking defines your network access to your EC2 instances. Amazon Virtual Private Cloud, VPC, lets you provision a logically isolated area within the AWS cloud, where you can launch your EC2 instances in a virtual network that you define. Alternatively, your AWS account comes with a pre-configured default VPC in each region. You can launch your EC2 instances into the default VPC right away. A VPC can also span multiple availability zones, AZs, in a region. You can add subnets in different AZs and launch instances into the subnets to improve fault tolerance in your applications. You can also use multiple layers of security to help control access to Amazon EC2 instances in each subnet. For example, you can define a security group, which acts as a virtual firewall that controls the traffic for your instances. Now, let's look at how these EC2 basic concepts are used to launch Amazon EC2 instances. To launch Amazon EC2 instances, first, you need to determine whether you want to run your Amazon EC2 instances in a single location or multiple locations, regions, availability zones. Select an Amazon machine image. Then determine which Amazon EC2 instance types and sizes you want. You will also need to configure network access and specify any preferred subnet on your Amazon EC2 instances. A default root storage is used to boot the instance. You can edit the root volume or attach additional storage to your instances. As an option, you can add tags to your instances. Tags are used to categorize your resources and help in searching and managing your resources. Configure security on your Amazon EC2 instances, such as configure security groups. You can also secure your login information for your instances, using key pairs, public and private key. With these simple steps, you can use Amazon EC2 to launch as many or as few instances as you need, within minutes. AWS Global Infrastructure Benefits. Here are the benefits of the AWS Global Infrastructure. Performance. AWS Global Infrastructure ensures high quality and uninterrupted performance. It offers customers a high-performing, low-latency, highly scalable, high-availability, secure cloud infrastructure and responds to changing needs fast, without any drop in performance. AWS provides customers with the highest levels of availability and reliability. AWS availability zones are designed for physical redundancy and provide resilience, enabling uninterrupted performance, with no single points of failure. Every component of the AWS infrastructure is designed and built for redundancy and reliability, from regions to networking links, to load balancers to routers and firmware. In addition, the AWS Global Infrastructure is built on Amazon's own custom hardware, such as custom, purpose-built compute servers, load balancers, routers, and silicon. AWS optimizes this hardware for only one set of requirements: workloads run by AWS customers. By using custom hardware, AWS provides customers with the highest levels of reliability, the fastest pace of innovation, all at the lowest possible cost. Security. Our core infrastructure is designed to meet the more stringent security requirements in the world. It is built to satisfy the security requirements for military, global banks, and other high-sensitivity organizations. Our infrastructure is monitored 24/7 to help ensure the confidentiality, integrity, and availability of our customers' data. Scalability. The AWS Global Infrastructure enables companies to be extremely flexible and take advantage of the conceptually infinite scalability of the cloud. Customers can provision the amount of resources that they actually need, knowing they can instantly scale up or down, along with the needs of their business. Companies can quickly spin up resources as they need them, deploying hundreds or even thousands of servers in minutes. Low cost. With the industry's most extensive data center footprint, the AWS Global Infrastructure enables more customers to benefit from cloud economics of scale and reduce the total cost of ownership, TCO, of their overall IT infrastructure.